is exposure to light and air. You remember here. Here H positive is given, acidic hydrolysis is given, SO positive is given, H positive plus water is given. Then this sodium replaced by hydrogen convert to carboxylic acid, otherwise does not convert to carboxylic acid. So remember, what is final product here? ONA. Now react with water, H2 plus water here. Okay. So now this sodium replaced by hydrogen to formation of benzoic acid. Correct statement. In chloroform, क्योंकि poisonous gas is exposure to air and light. So remember here, when chloroform, okay, everyone know CHCl3, chloroform. When chloroform react with O2 in presence of UV light, it forms phosgene gas COCl2. Everyone know COCl2 is formed. Remember here, poisonous gas is formed phosgene. Remember here, phosgene gas is formed here. What is formed? Phosgene gas. Okay. What is formed here? Phosgene gas is formed here. So remember here, phosgene gas is formed here. Okay. Remember, phosgene gas is poisonous gas. Okay. It is poisonous in nature. To prevent to phosgene gas, we added ethanol. Remember. To prevent phosgene gas, we added ethanol, C2H5OH. We added ethanol added here. Okay. To prevent to cause phosgene. Remember, when chloroform come contact with air and ultraviolet light in air, it convert to phosgene COCl2 poisonous gas. To prevent to poisonous gas, formation of poisonous gas, we did ethanol, because ethanol does not form, doesn't convert to phosgene gas. So remember this concept. Okay. So now second option is correct. Okay. P given carboxyl compound, only second. The answer will be second. Only answer in second is correct. Okay. To prevent phosgene, we added ethanol here. Everyone know. So remember this concept. Okay. Now next question number 56. Okay. Now remember your elementary reaction. What is elementary reaction? Elementary reaction are those reactions in which no intermediates form. No intermediates form. Single step reaction is known as elementary reaction. In elementary reaction, its coefficient defined to its order of reaction. Everyone know its coefficient defined to order of reaction. Okay. So remember this point. Here is given graphical question. Okay. What is given graphical question? Now Arrhenius equation. What is Arrhenius equation? Everyone know K is equal to A exponential K power minus E upon RT. So both sides taken ln multiply by ln. So we can write here ln K is equal to ln A. Ln E cancel out. Everyone know ln is equal to 1 by E. Okay. And E both are cancel out. So we can write here ln exponential K power minus E upon RT. Okay. Understood everyone? So we can write here log m into n. So now we can write here ln k is equal to ln a minus e upon rt. Okay. What is ln? 1 by e. So now 1 by e plus e cancel out. That's why it becomes 1. So now what is formula? This becomes to ln k is equal to ln a minus e upon rt here. 1 upon rt here. Okay. Now compare this equation. Y is equal to mx, mx plus c. What is intercept? ln a. What is x is given? 1 by t. Remember y is equal to mx plus c here. Okay. So now here y is equal to mx. What is given? 1 by t. X is given. X is 1 by t is given. What is slope? Intercept. What is intercept? C is given. ln a. In slope of the curve, what is slope of the curve? Minus e upon r here, slope of the curve. Okay. So here slope of the curve will be minus e upon r. So now it is slope of the curve. Okay. So now slope of the curve is minus e upon r. Minus e upon r is slope of the curve here. Okay. So remember this concept. Okay. So check here. What is intercept? Now distance taken on y-axis. Everyone know what is intercept? Positive. So distance taken on y-axis from origin. Okay. So now it is intercept. So now it is c is equal to ln a. Okay. Its value is given. What is intercept here? 1, 2, 3, 4, 5, 6 here. 6 is given. What is intercept here given? 6 here. Okay. So remember here intercept is given. What is intercept is given here? Understood? So now here intercept. What is intercept? 6 value. So 6 value here. Up to 6 value. So now 6 value is intercept here. Okay. In slope of the curve, activation edge is given. What is activation edge is given here? Activation edge is given here. This value. Okay. Okay. So now here activation edge is given. Slope of the curve. Okay. So remember here, what is value is given here? So put here value. Okay. Put here value. What is given? Activation edge is given. E is 6.64. R is given 8.3. The temperature will be rate constant E square minute inverse will be. Okay. So we have to find out this value. What is value is given? Activation is given. What is the value? 6.64. 6.64 kilojoule convert to joule. That's why multiply by 3 here. Okay. R value is given. What is R value is given? 8.31. What is value? 8.3. 8.3 value is given here. R value. Okay. Now we have to find out rate constant K. We have to find out rate constant K value here. Okay. So remember here ln6 is 6 values given. So 6. What is here value? Minus 6.64 10 to the power 3 here. Okay. R into R value is given 8.31. So now 8.3 put here value. Okay. 8.3 into temperature. Okay. Temperature is given also. What is temperature is given? The temperature rate with the rate constant becomes to E square. Okay. And now what temperature? We have to find out temperature. In case E square, its value is E square is given. So put here value. Okay. So now what is value here? Everything is given. Ln K is equal to ln E minus E upon RT here. Okay. So put here value. Now K is given En. So now here E square. Okay. Ln A 6 value is given. What is activation edge is given? 6.64. 6.64 10 to the power 3 here. Okay. Put here value. What is R value? 8.3 value. Now we have to find out temperature. Kelvin. Kelvin. Always temperature Kelvin. Okay. So now here. So we can find out here. Intercept value is given. C. Ln 6 value is given here. Okay. Now we can write here 2 ln E is equal to 6 minus 6.64 10 to the power 3 into 8.31 into T here. Okay. Understood everyone? Now what is ln? Now we can write here ln means 1 by E. In E cancel out here. So now it becomes to 1. It becomes to 1. So now here 2. Here is 6. Now 6.64 10 to the power 3 into 8.31 into T here. Okay. Understood everyone? So now we can solve here. After solving, okay. What is value here? And now this negative sign come to upside, this side positive. Now negative here. Now it becomes 6.64 10 to the power 3 divided by 8.31 into T is equal to 6. 6 minus 2, that's why 4. Okay. Now it's 4 here. Okay. So we have to find out T value here. Okay. So what is T value here? So now T, that means 6.64 10 to the power 1000. 10 to the power 3 means 1000. We can write here 8.31 into 4 here. Okay. So how much time divided? 25 times. 1000 by 4, 25 times. Okay. After it 8.3 is 0.8 times. Okay. Now multiply here. So 0.8 multiplied by 25. We get here 200 Kelvin. What is temperature here? 200 Kelvin. So remember, temperature will be 200 Kelvin when rate constant becomes to E square. At what temperature E square? Rate constant becomes to E square exponential की power 2 when temperature requirement 200 Kelvin. So temperature requirement is 200 Kelvin. What is requirement temperature? 200 Kelvin here. Okay. So remember this. Now next question we discuss. Okay. Temperature requirement 200 Kelvin. Okay. Okay, remember this 200 Kelvin temperature requirement. Okay, so now next. Okay, now next question we discuss. Okay, 57. Okay, we discuss question number 50. Now question 57. Okay, I will discuss question number 57 here. Okay, so what is image ordered displayed? Okay, so remember which of the following increasing order of polarity? So do you know polarity? What is polarity here? Do you know what is polarity? Question number 57. What is polarity? Remember polarity defined for measurement of dipole moment. Okay. Remember more polar nature. Why the requirement of dipole moment? Because dipole moment defined the polarity of any molecules. More dipole moment, more polar compound is understood. Polarity defined to dipole moment. More polar compound, more dipole moment. Okay. So remember dipole moment defined to polarity. Dipole moment. Okay. Dipole moment defined to polarity of molecule. Defined to polarity of molecules. So remember here. So dipole moment defined to polarity of molecules. Now which molecule is more polar? Remember everyone. Polarity dipole moment. Okay. Now it is more polar. Acidic hydrogen. Okay. We required acidic hydrogen. Acid group is more polar. Then will be alcohol. Then will be alcohol. Then will be ketone. And then will be ether group. Okay. So now remember ether group is less polar. So remember polarity order will be this. Acid is more polar. Then will be alcohol. Then will be ketone. Then will be ether. Okay. That's why here answer will be which option is correct? D is more. Then will be B. Then will be C. Then will be A. The third option is correct. Now question number 57. Its answer will be third. So third answer will be correct. Remember polarity. Why discard polarity? How much polar compound? Which molecule is more polar? Which is more less polar? To identification of polarity we requirement dipole moment. That's why dipole moment discard. Okay. So remember here acid group is more dipole moment, more polar nature. Why it is more electronegative element is present. Here is also more polarity. Better, that's why negative charge positive. Here is also polarity, less electronegative more. That's why negative charge positive. That's why two negative charge, two positive are more polar. Okay. More electronegative difference. That's why here also more polarity. So remember this trick. Okay. Remember this concept. Now next question discuss 58. Okay. Question number 58. Remember here question number 58 is very easy question. Remember language is something different. Do you know denaturation of protein? What is denaturation of protein? Do you know formation of curd? Formation of curd from milk. Denaturation due to heating effect, pH change, it causes denaturation. Okay. So remember, it causes a denaturation of protein. Denaturation of protein, primary structure does not change. Only secondary tertiary structure will be changed. Protein. Okay. Denaturation of protein, primary structure does not change. Only secondary tertiary structure will be changed. Remember this point. Okay. So remember here. Now it is given protein undergo reversible isothermal denaturation from initial state N to state D. Okay. Now here N state convert to reversibly D state after denaturation of protein. Okay. Temperature given 60 degrees Celsius. What is temperature given? 60 degrees Celsius given here. Okay. The concentration of both N and D are equal at equilibrium condition. Its concentration also equal. Its concentration x mole per liter at equilibrium condition. Its concentration also x mole per liter at equilibrium condition. At equilibrium condition. At equilibrium condition. Okay. When rate of forward is equal to rate of backward, that is equilibrium condition. Okay. Out here. And the standard enthalpy change denaturation is given. Standard enthalpy change means delage enthalpy change, delage not. Its value is given. How much value is given? 666. Okay. Kilojoule per mole. What is value given? 666 kilojoule per mole. Value is given here. Delage not. Okay. Standard entropy change for the protein open nature 60 degrees Celsius closer to. We have to find out delage not. We have to find out delage not value. Okay. So remember here at equilibrium condition. Remember here at equilibrium condition del G naught is 0. Okay. Remember here, we requirement times is given here, okay? The standard entropy change of the protein at degeneration 60 degrees Celsius closer to this value, okay? We have to find out del S naught entropy, okay? Everyone know Gibbs energy change formula, del G naught is equal to del H naught minus T into del S naught, okay? Remember here, both concentration are equal. Both concentration are equal. That means, what is K value? Equilibrium constant. What is K value here? Equilibrium constant. Remember here, concentration of product upon concentration of reactant here. Both are equal. X mole per liter, X mole per liter. That's why K equilibrium constant becomes to 1. K equilibrium constant becomes to 1. Everyone know? Remember what is formula here? Del G is equal to del G naught plus RT ln K Q. Reaction Q. At equilibrium condition, del G is equal to del G naught. What is here? Del G is equal to del G naught here. Remember this formula. Del G is equal to del G naught plus RT ln Q. At equilibrium condition, del G is 0. Del G is 0 always. Del G is 0, not del G naught. Okay, del G is 0. What is here? Del G is 0. Del G is 0. At equilibrium del G is 0. This quantity del G is 0 here. Del G is 0 here. But del G naught not 0. Not 0 is equal to 1. Not 0 here. Not 0 here. Okay. But remember here, what is formula here? Del G naught is equal to minus RT ln K equilibrium constant. Okay. But equilibrium constant value is 1 here. Both concentration equilibrium condition. That's why equilibrium constant 1 here. Now equilibrium constant put here 1. 1 means ln 1 is 0. That's why here del G naught also 0. That's why here del G naught also. Very important concept. Remember this part. Very important concept. At equilibrium condition del G is 0 but del G naught not 0. But at equilibrium condition concentration are both are equal. That's why K equilibrium constant becomes to 1. That's why here K equilibrium constant 1. That's why del G naught is 0 here. Okay. Del G naught is 0 here. That's why here 0 also, del G naught also 0 here, okay. 0, that's why what is formula? Formula becomes to del H is equal to T into del S, T into del S naught. What is formula? T into del S naught is equal to del H naught divided by T. What is del H naught here? Del H naught here value is given 666 kilojoule. And they are asking about kilojoule. Both are kilojoule. That's why no requirement to conversion 666. What is temperature here? 60 degrees Celsius. Now convert to Kelvin. Now 60 plus 273. 273 plus 60 here. Now 3 here. Now 3 here. Now 3 here. So 333. So how much time requirement? 3 means 2. Entropy change will be 2 kilojoule. Okay. Kilojoule mole Kelvin inverse. Kilojoule mole inverse Kelvin inverse. That's why answer will be 4th. Answer will be 4th. What is the answer here? 4th. Fourth answer is correct here. Okay. Remember what is conclusion this question? At equilibrium condition del G naught is not 0. But both concentration equilibrium condition reactant product concentration equal. That's why K equilibrium constant becomes to 1. That's why here ln K equal to 1. ln 1 is 0. That's why del G naught is 0 here. Del G naught 0 here. That's why formula because del H is equal to T into del S naught. That's why here del S naught is equal to del H naught divided by T here. Okay. That's why for its formula will be, its answer will be 2 kilojoule and an entropy change. That's why fourth answer is correct. Okay. Now next question. Okay. Now next question is given 59. Okay. Consider the following statement about the solution formed by mixing two liquid. Okay. Ideal solution thus form obey Raoult's law throughout the composition range. Correct statement. What is Raoult's law? Ideal solution, that means those solution which follow Raoult's law at all temperature and pressure condition. Okay. Temperature, pressure condition, it follow Raoult's law. Now it is A molecules, it is B molecules. Okay. So now interaction force of attraction are equal. Force of attraction are equal. Interaction force of attraction are both are equal. Okay. Interaction force of attraction. Interaction force of attraction both are equal. Interaction force of attraction both are equal. Okay. Both are equal interaction force of attraction. That's why here del H enthalpy change will be 0. Ideal solution. Change in volume will be 0. Okay. Understood? Change in pressure also 0, del P also 0. Change in pressure also 0 here. Okay. Remember here, ideal solution are those that follow Raoult's law throughout the composition range. Okay. The mixture of chloroform acetone show negative deviation from Raoult's law. Statement false is correct. Okay. Statement false is correct. Statement B. Chloroform acetone from negative deviation. Everyone know, remember this Cl is here, Cl is here, Cl is here. Now hydrogen, acetone here. C double bond, CS3, it is CS3 here, okay. So after shifting of bond, we get here negative charge, we get here positive charge here, okay. Now, it is due to more electron, del negative charge, del negative charge, del negative charge, positive charge here. So now positive charge, negative charge causes more attraction, okay. The attraction between AB molecule increases. Attraction, suppose it is AA molecules, chloroform molecules, and BB molecules. Okay. After formation, interaction AB molecules, interaction force is greater than AA molecules and BB molecules. Okay. That's why here more attraction. That's why here more attraction. More attraction. That means a negative deviation. More attraction, molecule associate. Okay. More attraction. That's why negative deviation. Correct statement. Okay. The mixture of aniline and phenol show positive deviation from Raoult's law. Wrong statement. It is also negative deviation. Aniline. What is aniline here? NH2 group. Now here NH2 group here. Okay. Now here aniline phenol is given. What is here? Phenol is given. Aniline phenol. Okay. Here is OH given. Okay. So now remember here attraction between this hydrogen nitrogen more increases. Okay. So now here attraction increases again. AB molecule attraction increases as compared to AA molecules as compared to BB molecules. That's why it shows negative deviation. That's why this option is wrong. C option is wrong. C option is wrong. B option is correct. A option is correct. A and B is correct. Okay. So now A and B, fourth option is correct. Answer will be fourth. Question number 59. Fourth option is correct here. Okay. Remember, attraction force. That's why change in enthalpy, change in volume is 0. Okay. But chloroform due to 3-chlorine, it appears positive charge here. It is oxygen negative charge. That's why attraction force increases between hydrogen and oxygen. That's why it shows negative deviation. Okay. In case of next, it is aniline and phenol. It is more electronegativity element, oxygen. More acidic hydrogen. That's why here positive charge here. Okay. Here is positive charge here. Here is negative charge nitrogen. That's why more attraction. That's why attraction increases between AB molecules. Between A and BB molecule. That's why here negative deviation. That's why wrong. C option is wrong. Only A and B is correct. That's why fourth option is correct. Okay. Now question number 60. Okay. Now next we discuss question number 60 here. Okay. Given below two statement, heating of NaCl with concentrated H2S4 MnO2 result the oxidation of Mn. Remember here. Question number 60. What is given here? Question number 60. Heating of NaCl with concentrated H2S4. Okay, so now here NaCl is given plus concentrated H2S4. Concentrated H2S4 is given. What is given here? Concentrated H2S4. Okay, with MnO2 and MnO2. What is given here? MnO2 also given. Okay, H2S4 plus MnO2 is also given. Okay, so now result reduction of Mn. Reduction of Mn. Sorry, MnO2. MnO2, result of oxidation of Mn. So remember here, MnCl2 is formed. MnCl2 plus sodium hydrogen sulfide is formed. Okay. So remember here, Mn plus 2, here is plus 4 oxidation number. What is oxidation number here? Plus 4. Here oxidation number plus 2. That's why reduction here, not oxidation. That's why first statement wrong here. Oxidation, not oxidation. Not oxidation, reduction. That's why first statement is wrong. Okay. First statement is wrong here. Okay, second statement. Heating of sodium iodide with concentrated H2S4 MnO result of Mn. Same reaction here is iodine, simple. Suppose we instead take NaCl instead of we take sodium iodide. Okay, instead of NaCl we take sodium iodide. In presence of concentrated H2S4, concentrated H2S4 in presence of MnO2. Okay, so remember here, MnI2 is formed. MnI2 is formed. Remember here, same product. Na sodium hydrogen bisulfate is formed. It is reduction. Reduction again here plus 4 oxidation number convert to plus 2. That's why reduction here. The correct statement reduction. This is a reduction of Mn. First statement is wrong. Second statement is correct. Okay. Third option. First statement is correct. Second statement is correct. Now third option. The answer will be third. Third answer is correct. Okay, understood everyone? Remember this. Now very simple question. Now remember question number 61. Now question number 61 is very conceptual. That's why remember how to solve question with trick. Okay, remember. Everyone know what is given here. Trans 2-butene open treated with Br2 plus CCl4 give following product. Okay. Everyone know trans alkene. Take the anti-addition. Anti-addition. What is product is from meso? Everyone know meso. What is product from meso? Remember here, trans anti-addition meso compound. Okay. Suppose here C is given. C is reacted with anti-addition. 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 C is the anti-addition. What is product form? Racemic mixture. What is product form? Racemic mixture. So racemic mixture is formed. Racemic mixture is formed. What is product form? Racemic mixture here. Okay. Now remember this car. Okay. What is trick here? Car. Car means cis anti-addition racemic mixture is formed. Cis anti-addition racemic mixture is formed. Okay. Now here meso compound we require anti-addition Br2 plus Cl2 CCl4 anti-addition. Remember Br2 plus CCl4 causes anti-addition. Okay. Now here is trans alkene. Trans is given trans 2-butene. Okay. So we require meso compound. This is meso compound or not? How to identify meso compound? Remember this trick. How to identify meso compound? Okay. So now remember this. How to identify meso compound. Okay. Now remember. Now it is given circle. Gauge form. Okay. It is front carbon. It is front carbon. It is front carbon. It is back carbon. Okay. Two carbon. It is front carbon. It is back carbon. Okay. One carbon is front carbon. One carbon is back carbon. Okay. Remember here it is front carbon, it is back carbon. Okay, now it is Br. Okay, so now front carbon, what is present here? Br group is present here. Br group is here. Methyl group is here. Okay, Br, methyl and hydrogen is present here. Okay, here Br, methyl and hydrogen front carbon. What is back carbon? It is methyl. Okay, what is here? Hydrogen. Here is Br. What is here? Br. Okay. So now, always eclipsed form decide to whenever we have to identify this is form at this whenever we have to find out this meso compound or racemic mixture, first convert to Newman position formula to Fischer position formula. So Newman position formula convert to Fischer position formula. First we requirement eclipsed form. First convert to eclipsed form. Eclipsed form represent to Fischer position formula. It defined to meso compound or not. To convert to eclipsed form means Br backside of Br, methyl backside of 180 degree rotate. Okay, so backside carbon. Now backside carbon rotate by 180 degree. Remember, it is Newman position formula. Newman position formula doesn't give information about meso compound. Okay, first convert Newman position formula to Fischer position formula. Okay, so now Fischer position formula, Newman position formula, eclipsed form. It's eclipsed form defined to racemic mixture or meso compound. To first convert to eclipsed form. Eclipsed form identification give all identification observed by eclipsed form, not other form. So remember, first convert to eclipsed form. So now 180 degree rotate, backside carbon rotate 180 degree. Okay. So backside carbon rotate 180 degree. So now it becomes 2Br. It's beside Br. Now it is Br. It's beside backside Br. Okay. Now what is here? Hydrogen here is methyl. Okay. 180 degree methyl backside. It's methyl backside here. Okay. What is here? Hydrogen backside here. So not meso. Not meso means symmetry. Not symmetry here. Br here. CS3 methyl CS3. That's why not meso. It is not meso compound. Backside methyl group is present. Methyl is present. Br hydrogen is present. That's why meso compound. That's why not meso compound. That means it is not meso compound. Understood? Because what is here? How to convert Fischer position formula? Now this front carbon. What is here? Br. Here Br, what is here? Methyl. So write here methyl. What is here? Hydrogen. What is here? Br. So write here Br. What is here? Hydrogen. The hydrogen here. What is here? CS. Now write CS. Not meso compound. No plane of symmetry here. No plane of symmetry. Now methyl is here, methyl is no plane of symmetry, no center of symmetry, no POS, no COS. That's why here no meso compound. It is not a meso compound. It is not meso compound. But in case of second, remember cis butene react with alkyne chemical. Both are cis. That's why it form meso compound. Both are cis. Cis alkene, syn addition. Cheminophore, syn addition. Okay. Remember cis alkene, syn addition. So remember here two formation of meso compound. Now meso possible or not possible? Check here. Methyl here, here hydrogen. Okay. Remember, at what angle rotate to it convert to backside OH backside to OH, methyl backside to methyl, hydrogen backside to hydrogen. So now backside rotate by 60 degree. Okay. So backside carbon rotate by 60 degree. So backside carbon. Okay. Backside carbon rotate by 60 degree. So now here backside here anti-clockwise. Okay. Anti-clockwise rotate by 60 degree. So now what is here? It becomes to OH, it becomes to methyl, okay, it becomes to hydrogen. So now OH backside of OH here, okay, now methyl backside to methyl here, now hydrogen backside to hydrogen here. That's why meso compound. Okay, now here OH, here is OH, both are OH, here is methyl, okay, here is hydrogen, here is hydrogen. That's why plane of symmetry. Here is plane of symmetry, POS. Okay, plane of symmetry. That's why meso compound. That's why it is meso compound. That's why here meso compound. Okay. Remember, first option is wrong. Second option is correct. Statement first is wrong. Second statement is correct. Okay. First statement incorrect. Second statement correct. Answer will be third. Answer will be third. Question number 61. Answer will be third. Understood, everyone? Very simple. Newman position formula always give information eclipsed form. Eclipsed form give information, not other form. So no, first convert to eclipsed form. What angle rotate? 60 degree. First 180 degree. OH become to OH side, methyl become methyl side, hydrogen become to hydrogen side. That's why plane of symmetry. That's why here meso compound. That's why option second is correct. First is incorrect. Okay. Remember everyone. Okay. Now question number 62. Everyone know this formula is highest occupied molecular orbital. Do you know HOMO LUMO? Highest occupied molecular orbital. What is LUMO? Lowest unoccupied molecular orbital. Do you know? Everyone know HOMO LUMO? Everyone know? What is here HOMO LUMO? Everyone know what is here HOMO LUMO? Remember here, highest occupied molecular orbital N2 molecule. Right here. N2 MOT diagram for N2 molecules. Okay. So right here neon, here right neon. Okay. Right, electronic configuration, it is 1s orbital, bonding orbital, 2 electron is present. Here is also 1s orbital, 2 electron is present. Here is 2s orbital, here is 2s orbital. What is here? 2s orbital. Here is also 2s orbital, here is 2s orbital. Okay. Now here 2p orbital. What is here? 2p orbital. Right here 2p orbital. Now here is also 2p orbital. Right here 2p orbital. Okay. Now 2p orbital here. Okay. So now 6 electron is also 1 2 1 2 1 2 configuration fully filled here 1 2 1 2 1 2 here. Okay. Now it's bonding anti-bonding. Now it is bonding anti-bonding orbital. Okay. Now is sigma 1 is sigma star 1 is it's anti-bonding. 2 electron is filled here, 2 electron is filled here. Okay, completely fully filled. Okay. Now here 2s. Now bonding anti-bonding orbital. Right here bonding anti-bonding. It is sigma 2s, sigma 2s. Sigma star 2s here. 2 electron is present here, 2 electron is present here. Now in neon more than 20 electrons. Okay, that's why here px orbital downside, upside remains same. More than 20 electrons, diagram will be changed. Okay. So now remember here it is px orbital, it is px orbital, it is py orbital, it is pz orbital. Okay. So px form sigma bond, it form pi bond, it is form pi bond. Okay. Between two atom 3 bond is present, the one form sigma, 2 form pi bond. 2 form pi bond here. Okay. But now here 1 is sigma bond, px form sigma. That's why here sigma 2px, sigma 2px orbital here. What is here? Pi. Pi 2py orbital here. Pi 2pz orbital here. Okay. Now star here, sigma star 2px orbital. sigma star 2px, it is pi to pi star 2py orbital here. Star means antibonding. Pi star 2pz orbital here. Okay. So now how many electron here? 6 plus 16. That's why 10 electron occupied here. 1 2 1 2 1 2 1 2 1 2 here 1 2. Now this diagram according to increasing order of energy. Increasing order of energy. Those orbital which occupied maximum energy. Those orbital which occupied maximum energy. So tell me, which orbital is the highest occupied molecular orbital? Sigma star 2px is occupied highest energy. It occupied highest energy. Highest energy. This orbital occupied highest energy. Okay, that's why here sigma star 2px. Okay, sigma star 2p. 2p sigma bond. It is pi bond. That's why sigma star. Okay. Now remember here it is occupied sigma. Understood everyone? So remember this sigma occupied least energy. Okay. Remember sigma. Third answer is correct. Answer 62, third option is correct. Answer 62, third option is correct here. Okay. So remember third option will be correct here. Okay. So remember this point, highest occupied molecular orbital. What is asking about? Highest occupied molecular orbital here. Which occupied highest? Sigma star 2px orbital is highest molecular orbital. Okay. Remember this concept. Okay. Now next question is here 63. Okay. Now question, do you know hyperconjugation effect? Everyone know hyperconjugation effect? Do you know hyperconjugation effect? Which of the following carbon is stabilized by intermediate of the empty p orbital? Okay, remember here is positive charge here. What is here? Positive charge. Double bond, single bond, double bond. Here is positive charge. Here is given CSC. What is given here? CSC. Okay. So remember here. Now what is carbocations? What is electronic configuration of carbon? 1s2, 2s2, 2p2. Okay. Now 2s subset 2 electron is present. In p orbital 2 electron is present. Okay. But removal of 1 electron, electrons from here. 2s subset lower end, that's why removal of 1 electron here. Okay. So remember here 1 electron is removed. Positive charge means removal of 1 electron from here. What is here? 2s orbital 1 electron, 2p orbital also 1 electron. The vacant orbital here is vacant orbital. Okay. Empty orbital. Okay. So now here empty orbital. Okay, empty orbital, p orbital. Okay, now this p orbital of carbon, this empty orbital, p orbital of carbon. What is here? P orbital. What is here? P empty orbital here. Okay. So now here CS3. Now the sigma bonded. All are sigma bonded here. Remember here CS3 is given. Okay. Now one hydrogen is here. Now remember it is CH bond. It is CH bond. It is CH bond. Okay. So now it is filled orbit. Now CH4, this filled